What we need to do now is to quote two members of the family of curves to this equation here that is going to be straight lines. From observation, since we can assign different values for d and c into this equation, I'm going to assign d to be equal to 0 for both of that curves, because as long as d is equal to 0, this term is going to disappear. And what that is going to leave me with is a form of y is equal to mx plus c, okay, which are going to be straight lines. So if I were to let's say d be equal to 0 and c be equal to maybe 0, what I'm going to get is y is equal to 1 over 2 3x plus 0 plus 0. Okay, that is why one of the member of family of curves that is going to be straight line can be 3 over 2x. And if I were to once again let d be equal to 0 and c be something else, okay, let's say 1, I'm going to get another straight line too. If I were to sub this in, y is going to be equal to 1 over 2 3x plus 0 plus 1. So y is going to be equal to 3 over 2x plus 1. Okay, so these are the two possible curves. You can just go for different values of c to get the other two curves, the other two members of the family of curves that are straight line. Okay, as long as d is equal to 0, the answers that you have gotten should be accepted. Now what we need to do is to choose one of the lines that we have and sketch it together with one of the curves where the asymptote of that curve, okay, it is going to be represented by either of the line. Okay, so we are going to choose one of the line first. What I'm going to do is I'm going to go for this line. Okay, if I want to turn out this line as the oblique asymptote to the to that curve, right? What I need to make sure of is c to be equal to 1. As for d, it should be able, I can let it be just anything. Okay, I'm going to show you what I mean. I'm going to let's say d be equal to 2 and c be equal to 1, which means that the particular solution, okay, it is going to be equal to 1 over 2 3x plus 2e to the power of minus 2x plus 1. Rearranging this, I can get 3 over 2x, okay, grouping it with 1, okay, then this is going to cancel off the 2, so I have plus 1 over e to the power of 2x. According to what we have discussed in graphing techniques, okay, the definition for oblique asymptote, it is the behavior of y when x tends to plus or minus infinity. So looking at this equation as x tends to plus or minus infinity, can you see that this term here is going to disappear? It is going to become negligible, so y is going to adopt the behavior of this, which happen to be this straight line. Okay, that is why this curve that we have here is going to have an oblique asymptote that is going to be represented by this linear line, which is also going to be that member of the family of curves of this general solution. Okay, so let's sketch this and this together. Okay, it is going to give me the answer to the last part of this question. Okay, so this is the y-axis. Okay, and the x-axis, this is just a linear line. Okay, that is going to have a y-intercept of 1. Okay, so this is y is equal to 3 over 2x plus 1. As for this curve, if you were to press into your graphing calculator, you're going to get a curve that is something like this. Okay, and it is going to tend to the oblique asymptote of y is equal to 3 over 2x plus 1. Okay, and this is y is equal to 3 over 2x plus 1 over e to the power of 2x.